Okay, so yeah, this is about comparing approaches for new audio worklets. So the question I was asking myself is it worth using WebAssembly for new audio worklets? So we know that we can create audio worklets to create custom audio nodes using JavaScript or WebAssembly, and we've seen WebAssembly being used to port existing libraries. But what about new audio worklets? Is it worth using WebAssembly? And this bears like a kind of more latent question about at which level. So of course, we can see the Web Audio API as a kind of implementation of the classic paradigm, the music end paradigm, where we see a music program as a graph of unit generators. And so in Web Audio API, these unit generators would be the audio nodes. And we usually think in terms of oscillators and filters, but we can see there's a kind of an implicit abstraction in that we can encapsulate this into a synthesizer, as we just saw in the previous presentation. We can create more complex algorithms and encapsulate those as unit generators, and then create a graph of synthesizers and effects and so on. So there's a question about at which level do we want to work when we create audio nodes, audio worklets, and specifically using WebAssembly. So WebAssembly, of course, is the idea of this kind of bytecode format that allows you to compile different languages and run them on the web. But what's kind of cool is that you can run it in many other places now. So even a microcontroller, for example. So it's kind of an exploding field, WebAssembly, and it's quite interesting. So it's kind of becoming the new Java virtual machine of sorts. And perhaps the potentially most popular languages would be using C++, and of course Faust. But here I'm looking at kind of basic languages like C++, or more popular recent addition is AssemblyScript, which is a TypeScript that can compile or compiles to WebAssembly. So how to use WebAssembly for audio worklets is actually audio worklets themselves are not trivial as compared to script processor nodes. So you have to do a lot of things like registering, loading, dealing with parameters and so on. And WebAssembly is also not trivial. So how to connect both things is not immediately obvious. So there's documentation for each thing in the respective documentations. But for connecting both things, I use these tutorials from both the Chrome team and the Firefox Paula Denat at Web Audio Conference. And so these were very helpful for also because the implementations are slightly different. So understanding how to use WebAssembly in audio worklets. So that's how I started this project. Then, of course, in terms of related work, we've seen lots of libraries ported to through WebAssembly to the web, like Faust, Csound, Maximilian, or Essentia. Most of these can be seen as music end languages or music end-like systems. That again, my question is about what if I want to create a new audio worklet from scratch? So here I compared mainly 3 different languages: JavaScript, C++, and AssemblyScript, and at 2 levels of granularity. One would be in terms of WebAssembly, one would be to call WebAssembly 1 call per sample. So if you want to do sample accurate processing at the JavaScript level and then optimize parts of that. Or perhaps the more like normal approach would be to take the buffer. So in audio worklets, you're handed a 128 samples buffer. You can handle this directly to WebAssembly and do all processing in WebAssembly. And so this would be the pure JavaScript approach. Here, what I did was to implement an algorithm that you don't have in the Web Audio API. So this is a sawtooth band-limited sawtooth oscillator using the polyblep algorithm. And so, of course, this is the simplest approach. You are already using JavaScript, so you don't have to do so much, only deal with the audio worklet. And the code, as you can see, can be quite short. I mean, it's a high-level language, but still, of course, when you do signal processing, you still tend to use kind of C-like syntax and typed arrays and so on. So it's perhaps not so different from doing C++ actually. And it has the problem of a garbage collection, which can make it makes it less predictable, so you can have like an unpredictable cost at any point if you're not careful. Then this would be the C++ approach. Here the question was, how do we use this C++ code in JavaScript? So normally in the music end paradigm, we're used to kind of see an object-oriented mapping of the unit generators to objects. So it would be nice if we can just use C++ objects in JavaScript. So what you can do for this is use mbind, is this feature that allows you to interface with C++ in an object-oriented way, but it has the issue that it generates a lot of glue code. So it's basically you generate a WebAssembly file, but also lots of JavaScript that wraps this WebAssembly. And then how to load all this code is a bit different between Firefox and Chrome. So it becomes a bit complicated. And then, so the one in top is the sample-based example. And then for using the buffer-based example, you need to start thinking about memory. You need to think about how to share memory between JavaScript and WebAssembly. So a common practice is to call the malloc function from the JavaScript side and then wrap the memory in a typed array and then handle this pointer that you get from malloc to the WebAssembly side. Then the last version is the assembly script. In a way, you can see it as best of both worlds. So you have like a TypeScript syntax, very similar to JavaScript, and you've got a Wasm output. What I found really interesting is that the language, the tooling, the documentation, everything is targeted to Wasm, so it makes it very easy to understand what you're doing and what you can do with the bytecode with the Wasm format. And we've seen, it's a new language, we've seen already quite impressive demos like JavaScript Music by Peter Salomonsen, which I think will be presented at this conference as well. And then assembly script doesn't allow you to map the objects directly as we saw with mbind, but it does have JavaScript-like modules. So you can basically create your module and export functions and you do everything you would do in JavaScript and then use it from JavaScript as you would use a JavaScript module. So it's quite convenient. And then for the memory, there's also a way to offset the start of the code in the Wasm binary. So you have like a bit of a chunk of memory that you can work to share it with JavaScript. So I did a bit of a performance comparison. Excuse me. So here I implemented 3 algorithms. The saw oscillator is the one I've been showing with the examples. Then was inspired by a comment in one post by Paul Adenauer about the sine oscillator being implemented as using the sine function in Firefox. So this looked like a kind of low-hanging fruit for doing something that you can compare to native. So that sawtooth is something that would be an example of something you want to do that is not available in the Web Audio API in terms of like the low-level audio nodes. Whereas the sine oscillator would be something we can compare to a native version, and also added a backward low-pass filter also based on the Firefox code that we can also compare to the native code. So I implemented these 3 languages, and then the per sample and buffer based, and then I ran a test that was thought from a user point of view. So instead of looking at the load or the time it takes to compute a function, the question is how many audio worklets can I create in an application before the thing starts to glitch consistently. So we can have some spurious glitches as well. That was a bit complicated, but to make it a bit objective, the test was to stop when it's really, really distorted all the time. And so these are the results. The bottom is the sawtooth oscillator, so it's the one that doesn't have a native version. So if you want to compare to the top, you need to scale the graph a bit. And at the top, we can compare native and JavaScript and all the others. So there were kind of striking differences between platforms. Particularly for JavaScript versus native, I found like Chrome tends to favor the native implementations, whereas in Firefox, it seems that, by the way, Firefox is the blue and Chrome is the orange, of course. So in Firefox, it was quite surprising that the JavaScript is quite fast and can actually reach almost native or something similar to the native implementations. I have to say this is done with Firefox 99 and Chrome 100. Current versions may change completely. I think the current version of the filter is much faster in Firefox, but also in Chrome, this doesn't work anymore because now I think there's a limitation of the number of WebAssembly memory instances that you can instantiate to something like 100. So none of this works anymore. The test, but of course you can still use all the implementations. Then another interesting fact is that still the WebAssembly, it's not so easy to make it faster than JavaScript. Actually, it's still complicated. Clearly, the thing is that using the per sample approach is a lot slower, so that this shows that there's a significant cost in making a call from JavaScript to WebAssembly and back. So this means that the story is quite clear. So that to take advantage of WebAssembly, what you need is something really expensive running on the WebAssembly side and minimize the communication. So back to the original background question, this kind of biases the API a bit towards making more complex things. For example, whole synthesizers inside the audio worklet, as opposed to doing like basic things like oscillators and filters. And then the assembly script performance is a bit mixed. It's a bit hard to make it perform at the level of both C++ or JavaScript. I guess this may change in the future. So in terms of comparing, sorry, I'm a bit unaware of time. I don't know how I'm doing. Okay. I still have 20 minutes? No. That would be so. I've done 20 minutes already. Okay. Well, so I'll make it short then. So in terms of Wasm versus JavaScript, so from the experiment, so the idea was to look at it from both the how easy of use and the performance. So from the point of view of the ease of use, well, Wasm is quite hard to use. With audio worklets, you've got to load the Wasm code in the audio thread along with the audio worklet code. You have to deal with how to manage the memory. You have to add an extra tool chain, an extra language. You have to think about how to interface the code inside the WebAssembly. And in terms of performance, there's a clear penalty in the communication. You can have improvements. I think this experiment hasn't really shown the improvements, but I think they're quite likely. And of course, there's some advantages, such as not having garbage collection and the possibility of using other languages, which I think is perhaps the most promising aspect of WebAssembly. There are also quite a few limitations of this study. So I only tested very simple algorithms. So again, it would be interesting to test more expensive algorithms, not necessarily complex, but at least more expensive algorithms. And this was only run in one machine. I didn't test on mobile. So it might be that the differences between platforms and between implementations are quite diverse. So it might be that this kind of eases a bit the difference in performance between WebAssembly and JavaScript. So yeah, for future work, apart from more expensive algorithms, one thing that would be really interesting is to look at the WebAssembly code itself, because there's a text format you can try to interpret. So we could see what's going on from the Wasm generated by the different approaches and see why they perform better or worse. And of course, we could do this with all the different languages that you can use for WebAssembly. So, in conclusion, the question was, for new audio worklets, would we use JavaScript or Wasm? The answer is always complicated, of course. In terms of ease of use, well, it does increase the complexity, so you need some reason to actually use Wasm, for example, because you want to use a different language or something. From this point of view of the ease of use, I found that assembly script strikes a quite nice balance. It's quite easy to use, and hopefully the performance will improve in the future. And in terms of performance, as we've seen, it depends on what you're doing. So it might not be worth it for really cheap stuff or things that run quickly, but it might be worth it if you run more expensive algorithms. So that would be a sort of conclusion. Still, I think Wasm is very promising for other reasons, like being able to run your code anywhere, being able to write other languages. But still, for audio worklets, I think it's a bit mixed. So that's it. And I'm happy to take any questions.
So thank you very much. Other question in the audience? Yes.
Oh, hello. So I was wondering about the speed differences. So is everything compiling down to WebAssembly? So JavaScript is just faster?
Sorry, can you repeat the question?
Oh, so for all these different languages, are they all compiling down to WebAssembly? And if so, for JavaScript being faster, is that just an easier compilation process, or?
Well, JavaScript here didn't compile to WebAssembly. JavaScript is JavaScript.
Okay, so everything else is compiling to WebAssembly and then being run.
Yes.
Oh, okay. Interesting. All right.
Hello, thank you for the talk. I'm still wondering why you should evaluate WebAssembly in this scenario, because you have no performance gain. It's more complex. I'm super skeptical on the fact that you will find performance gain because of the nature of WebAssembly keeping, the communication costs with the JavaScript world. So JavaScript is compiled in a way by the VM. So it was interesting to evaluate WebAssembly. I've done WebAssembly benchmark on other scenarios. Sometimes it's great, most of the time it's not. It's great to reuse code, like I've been working with Adobe to take C++ code to make it WebAssembly. But why do you say at the end use WebAssembly for complex and JavaScript for simple audio worklet? What do you mean by complex? Like, do you think it's easier to take existing code base doing audio processing in C++ and then compile that to WebAssembly? Or is it because of the nature of JavaScript making it more complex to write?
Well, I have to say it is a potential take home, because actually I haven't really proven anything for complex code that you're right. So far, in only some cases, there was some of the C++ code that could be faster than JavaScript code. It is an expectation that if you have something really expensive, it could actually be faster. I'm not really sure. You seem to be skeptical. But it's a claim that you see around. The other thing is, of course, the garbage collection. This is something that, for complex code, is sort of an advantage to be sure that you're not being garbage collected anywhere. So that would be an advantage as well for complex code.
Yeah. Anyway, you're right. You need to do some testing and evaluate it. Garbage collector could be great because you're doing real-time processing, and you should avoid garbage collector at all costs to have, cuts in the UI thread. Oh yes, interesting. So thanks for the evaluation. We'll see if you manage to find a scenario where WebAssembly will be better. Thanks.
More of a comment than a question, but I'd be curious what the performance trade-offs are for non-audio data. Like, for example, if you're doing very rich, dense FFTs and then moving the FFT data down through a chain and then bringing it back into the audio domain, for example. So it lives its life as non-audio data, as kind of frequency spectrum data for a while, and then manipulations are done on that. I don't know if that was part of your benchmark suite or if you stayed purely in the audio domain, but I'd be curious to see if that's kind of one of those zones where Wasm might give the boost that you're looking for.
Yeah, so I think in alignment with what he said, there's some existing, I found a blog post doing something very similar to this, and comparing WebAssembly to JavaScript for non-audio stuff, and it was a similar result. The Wasm was not very fast, but that was back in, I won't dare to say, but it was many years ago actually. So I think that the WebAssembly is improving in performance, and you can see some people. I don't know. I can't tell you exactly where, but there's some places where it's being used for accelerating. I think, for example, from the machine learning community, I've seen places where the clear advantages of WebAssembly. for, yeah, as you say, for offline type of work. For online, there's a chance that you don't have so much time actually to leave it work for enough. So that's kind of the question again.
A last question.
I'll be quick. It's a bit related to what David said. So for me, it's easier now, much easier, to write DSP programming that becomes in the end an audio worklet using domain-specific languages, because when you need sample accuracy using the Web Audio API, you don't have any choice but making audio worklets. And programming complex DSP, well, complex, not so complex, but as soon as you have to deal with sample accuracy, the code can become quickly cumbersome in JavaScript. So something that I'm using FOST, but in one line of FOST, you can create something that you will take maybe hundreds of lines of JavaScript in an audio worklet. So in that sense, for me, it's easier to write directly at the audio worklet level. And what is interesting with the Web Audio API is that for some parts of the processing, it's easier to reuse Web Audio nodes like analyzers for FFTs and so on. And for example, with the guitar tube amplifier simulators that we wrote, we really exploit the dynamic behavior of wave shapers that we cannot find exactly as easy to use, or they do not exist in FOST or in other languages. So for me, taking the best of both worlds is really the best way to develop web applications with Web Audio. Okay, that was just a conclusion, not a question.
Yeah, so I would agree. So basically, yeah, all this project is a bit of an interest of looking at Wasm because of it's a really, really interesting for this reason, for being able to use so many different languages. So that's the real interest, I think. But of course, you would also want it to be fast, at least as fast as JavaScript. So
thank you very much.